Welcome back, everyone. Today we're going to be talking about 7.1 radical expressions in graphs. This is probably going to be a two-part video because the graphs are kind of separate. It's kind of its own procedure, and the first part, this video, is going to be talking about radical expressions. So let's go ahead and get started. So the first example we have is square root of 36, which I know essentially everyone here is going to know that it's 6. Okay, why is it 6? The square root essentially should be written like this. So most square roots are written without any sort of number inside, and this is implied that there's a 2. What does that mean? What does this 2 in this spot mean? Okay, that 2 means we're asking what number times itself twice, 2 times, gives us 36. So if we're thinking about that, 6 times 6, that's 1, that's 2 times, equals 36. Therefore, the square root of 36 is 6. So actually, the square root can be written as this or this, but you will almost never see it written this way. Okay, there's an implied 2 right there. So square root means which number times itself twice is the answer underneath the radicand. Okay. Underneath the radical, I should say. Now, so let's get into more complicated roots. So a number whose nth root, got to add the roots here, equals a. So just as before, and we said the square root essentially means what number times itself twice gives us 36, and so we get 6 times 6, so the answer would be 6 here, because 6 times 6 equals 36. Now we're thinking, okay, what times itself n number of times, that will be a. Okay, and that would be our answer. In other words, we can write it this way. So if the nth root of a equals b, then b to the n power equals a. So b multiplied by itself n times will give you a. So that's just the reverse of that. Okay, let's put this into practice with a few examples. So if we have the cube root of 27, it's saying what number times itself 3 times will give us 27. Usually you need to think of small numbers, especially when this number gets bigger. That means that there needs to be a number times itself multiple times. So the smaller the number, it's usually better to start with that. So the cube root of 27, what times itself 3 times will give you 27, and that is 3. Okay, next one. The fourth root of 16. The fourth root. So what times itself 4 times will give you 16. So 2 times 2 times 2 times 2 will give you 16. And a way to break that down is you can say this times this. Oops. This times this. That's 4. 4 times 4 is also 16. So the answer is 2. However, and we're going to learn this later, is it only 2? Well, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. So really this could be plus or minus 2. Okay, and we're going to come up with a rule in a second about how we can get to these fourth roots, sixth roots, any even root. This is just the reverse, so now we're saying, okay, what cubed equals 27? So that is clearly 3, because we're just doing the opposite as above. And then what to the something power equals 16. So we can say, all right, 2 to the 4th power equals 16. This is another way of thinking about it, okay? This can be rewritten 2 ways, either as the 4th root or some number to an exponent equals that number. These need to match, okay? So that exponent needs to match. This is just another way of reversing it. So it's kind of like when you get into logarithms, it's very much in a similar fashion as that. So now let's do more cases with the nth root, and this is where we're going to see patterns with positive numbers and even odd numbers with the roots. Okay, so in case 1, we have where n is a even number, okay, that means the root number. So, for example, this one, you're like, oh, there's no number. There is a number. It's right there. Okay, it's an implied 2. Because there's no such thing as the one root. Okay, what times itself 1 times gives you the number that's just nothing. I mean, it's just the number. So, here we have an even number and it's positive. Okay, what's going to be the case here? And that was kind of like this example up here. Notice how we had a plus or minus. So that's a little hint. So here we have 8 times 8 could give us 64. Or it could be negative 8 times negative 8. Now, the thing is, it can't be 8 times a negative 8. These have to match because it's times itself. So it's not like you can mix and match. They have to simply match. So we can write this as plus or minus 8. Okay? So either it's a positive 8 times a positive 8 or a negative 8 times a negative 8. But either way, those two numbers need to match up. So now we're going to talk about the 4th root of 16. We already did this problem up here, and we saw that it was 2 times 2 times 2 times 2. Or it could be negative 2 times negative 2 times negative 2 times negative 2. Okay? 4th power. That means times itself 4 times. And there's 2 different answers. Therefore, plus or minus 2. So anytime you have where the nth degree, the nth root is even, and then it's a positive number we're talking about underneath the radical, then we're talking about using plus or minus 2. Okay, so think plus or minus here, plus or minus. Okay, let's move on to case 2, where n is an even number. Okay, so we're talking about the root number, not the number underneath the radical. So that's an implied 2, that's an implied 2. And then a is negative number. Okay, so here we have negative 25, and here we have negative 100. Some of you might think, oh, it's just negative 5, it's just negative 10. Those are incorrect responses. Because if we have a negative underneath the radical, we need to say what times itself gives us negative 25. So what times itself? 2 times. So negative 5 times negative 5 gives us positive 25. There's no way for us to get to negative 25 with multiplying an even number of times by itself. Okay? So if you notice the pattern here, anytime we have positive numbers, no matter if they're always positive, no matter how many times we multiply them together, whether it's 3 or 4 times, you're always going to get a positive number. Okay? If we have negative numbers times themselves, it changes. So if we multiply it by a negative or an odd number of times, we're going to get a negative number. If we multiply by a positive number of times, or an even number of times, we're going to get a positive number. So if I multiply it 4 times by itself, negative 5 times negative 5 times negative 5, that's going to give me a positive number because we have negative times negative is positive, times negative is negative, times negative is a positive. And if I multiply it 5 times by itself, it's going to be negative again. So odd is going to give us negative powers. Even is going to give us positive powers. And that's why if we try to take an even root of a negative number, we're going to get no real solutions. No real solutions. Because we're going to get imaginary numbers. Okay, we're almost done here. Just got a little bit more to go, and then we're going to take our break. So case 3, where n is an odd number. Okay, so when n is an odd number, that's what we're talking about. 3rd roots, 5th roots, and so on. Okay, so there's our odd number, and we already know that this is 3 times 3 times, let me use green like we used before. 3 times 3 times 3. Okay, gives us 27. What about negative 27? And you're thinking, oh man, that's going to be an imaginary root. But not because it's an odd number root. So this could be -3 times -3. That gives us +9 times -3 gives us -27. Okay, so in this case, our only answer, there's only one answer. It's not like plus or minus, there's only one answer. And in this case, it is, this one is, let's write the answer here in red, 3, and then equals 3. And this one equals -3. But there's only one answer. It's not plus or minus, because the positive would only give you 27. Multiplying 3 times itself only gives you 27. And multiplying -3 times itself 3 times only gives you -27. There's only one answer for the nth root of a when it is odd. So we'll go ahead and find each roots real quickly here, and then we'll save the rest for the next video. So the third power, the third root of 64, what times itself 3 times gives us 64, and that is 4. Okay, 4, because 4 times 4 times 4 equals 64. Okay, we have an odd root number and a negative number, so we can do this. In this case, we're asking what times itself 3 times gives us -25, and that is -5. -5 times -5 is +25, times -5 is -125. Now, anytime we have a fraction, we can just apply our normal rules of exponents. So we could rewrite this as the third root of 8 over the third root of 27, if that makes it easy for you. And then that just becomes 2, and then that just becomes 3, and that's our answer. 6th root of -64. I don't really need to do much math here because I recognize that this is even, and this is negative. So if that's even and that's negative, this is going to be no real solutions. This is going to give us an imaginary number. Now, if this were an odd number, we would have a chance, but since it's not, we're done. Okay, this is an odd number root, so we know we're only going to have one answer. There's going to no, oops, I'm undoing. So we're not going to have imaginary solutions. So this is going to be what times itself 5 times gives us 32. That is 2. Don't know why the decimal appeared. Okay, and now we have the cubed root of 10. This is also going to give us one answer, but this is as far simplified as we can keep it, so we're just going to leave the answer like this. Hope this gave you some clarity as to some of the different degree roots that we have, and I'll see you next time so we can go over graphing.